ask questions. Please don't feel shy. Okay, so we're going to do 2.2a. So we're going to call this A. And it's just the first part of 2.2, or the second part is all calculator and stuff, okay? All right, so the first thing we're going to talk about when you're solving systems of solving a system of equation means to find all points of intersection. That means you're finding your x and y values. Okay, so what I want you to look at, it says, how many possible points of intersection for two lines? Okay, how many solutions to a system of linear equations? So what I want you to do, and one thing we know it's a system, if you see right here, this little squiggly thing, okay, that's a system. There could be 3 equations, you can have 10 equations with that little thing there. We want to know where they all intersect. So what you do right now is to graph each of these really quick, each set. Case number 1, case number 2, case number 3, and then we'll come back and discuss what kind of intersection we have, okay? Hope you had time to graph. So let's look at each system. So if we look at this first system, it crossed at one point right here. We don't know exactly what that is. You can estimate it right now, but right now for this purpose of what we're doing, I don't need to know exactly what it is. What I just need to know is that it does cross at one point. So if you have intersecting lines, that's better. Is that too dark? I feel like it kind of glares on this side. So if you have intersecting lines, one solution. On the second one, I wish this recording I can make them nice and neat lines. So on this one though, there are what kind of lines are these? Parallel. Thank you. Parallel lines, and they have no solution. They'll never intersect. And so this last one over here, case 3, I get it to move. What I did is I solved the second equation for y and to graph it, and it comes out to be the same exact as this one. And so I kind of dashed it on there with the blue. So we have the exact same line. So here it's the same line. And you'll have, what do you think? How many solutions will you have here? Infinite. All those points are true. Any point that you pick on the graph will make it true for the other one. Infinite solutions. So you can have no solution, infinite solutions, or one solution, okay? Now, that's graphing. We don't always do it by graphing. Do you remember all the different ways that we did it before? If not, let's move on. First one we're going to do is substitution. This is how you solve for systems without using graphs. This is algebra, okay? So the first thing you're going to do is you're going to solve one equation for one variable, okay? Doesn't matter which equation you choose, you're going to solve it for one variable. Then you're going to take that, whatever you solve for, and you're going to substitute it into the other equation. Okay, and then the next one is you're going to solve for that variable. This, when you do this, you should only have one variable when you do this, okay? If you have more than one, then either you just missed it or accidentally left that variable in there, but you should only have one variable because you can only solve it, can't solve it if you have 2 of them in there. 3 is solve for the solve for that variable. And then lastly, substitute to find the other variable. Does this ring a bell? This will take time and space. I just want you to know, okay? So understand that when we get to, so just make sure that you are ready for that part. Okay, so let's do this one. The first thing we need to do is we want to solve for one of the variables. It doesn't matter which equation you pick. I personally would take the top one. Anybody see why I would do the top one? Y is like, it only has a 1, right? 1y. When we see this only has 1y here. So it might, even though it's negative, it'd be probably, I don't have to worry about fractions when I have to solve for y, okay? So I always kind of write myself a note. I'm going to solve for y. So I'm going to take 2x minus y equals 11. And y'all solve for y. What do I do now? Subtract 2x from both sides. I highly recommend, you don't have to when it comes to these, is I always write it in slope-intercept form so I can see it, you know, but you don't have to. Now I have a negative y, so I have to get rid of the negative. I tell students divide by a -1. You can multiply by a -1. You may have been taught just to change the signs, which is fine. So that gives me 2x minus 11. Okay, so this is just step 1. Solve one equation for one variable. Okay, so that's what we did here. Okay, step 2, now we're going to have, now substitute into the other equation. So we're going to take the second equation that we didn't use, which is 3x plus 2y equals 6. And in place of this y, we're going to put in 2x minus 11. So we have 3x plus 2. So I just put this up in here. Okay, and then it says number 3, solve for that variable. So I should only have x's there, and that's all I have. So we're going to combine like terms by distributing. 2 times 2 is 4x. 2 times a -11 is -22 equals 6. Uh-oh, where's my 6? Oops, I must be off the board. Guess you can't write too far away. Any questions so far? Does anybody have any questions what I've done? Okay, solve for x to no? Did I write something wrong? Yes? Nope. So I have 7x minus 22 equals 6. Add 22 to both sides. I get 7x equals 28. Did y'all get x equals 4? Yes. Okay. Remember, this is a point. So in case you forget, write yourself a little parentheses, you know, with the comment, and then you're trying to find this as your solution over here. Okay, so now take the 4 and substitute it into the equation. I will substitute it in this one right here. Because I'm solving for y, and it's already y equals. You can solve it into the other two if you want. It doesn't matter, okay? So y equals 2 times 4 minus 11. 8 minus 11, so I have a -3. So my solution is 4, -3. Okay. There's a few things that you may not do. I'm going to show a lot of steps to make sure everybody's good, okay? Any questions so far? I'm going to pause. Okay, so for this one, I'm solving this one because of this x. Equation for x, and I get -6y plus 2. I'm going to take the x and substitute into the equation above, so don't plug it into the original. Like someone said, you'll get a weird answer. So now with this one, we know that okay, so now solve for y. Again, all your variables should be gone. I mean, your other variables should only have 1. I know how to multiply. 6 times -5 times 6 times -5 is a -30y plus 10 plus 4y equals 36. So y'all get -26 plus 10. I'm just make sure All right, I got negative 26, y equals 26. So you got y equals negative 1. Okay, so again, it doesn't matter which one you choose. Again, I'll probably substitute it in there because it's already solved. So I know I'm going to have a negative 1. So x equals negative 6 times negative 1 plus 2. I got x equals 8. Yeah, so be careful. It is a point, so please write the answer as a point. All right. Let's try the next one. Let's just kind of do this together. All right, so we're lucked out. We've been blessed. It's already in this form, you know, so I don't have to worry about it. So I'm going to take that y and substitute it into the 4 times y. So I'll have 4. Oh, my. Writing with a highlighter. So I'm going to do 4 times, and in place of y, I'll put 3x plus 1. Distribute. And then if I subtract the 12x from both sides, y'all agree that the variable drops out? So I get a 4 equals 3. So at this point, there's no variables. When your variables drop out, you have to ask a question. Is this a true statement or a false statement?
False.
False. If it is a false statement, this is a false statement. False is not our answer. Okay, this will never be true. So if it's never going to be true, what kind of solution do we have?
No solution.
So our answer is no solution. So what kind of lines are these? Yes. Parallel. These are parallel lines. Okay? So false is not your answer. Make sure you answer what kind of, if it's solution or no solution.
So basically you wouldn't do like 12x minus 4. You would do 12x by itself.
Yeah, I would try and just like move the variables together.
Okay.
And then, I mean, you could do it all at one time and you wind up with 0 equals some, you know.
Okay.
So did you get 0 equals negative 1 when you did it?
Oh, I didn't.
Oh, you didn't follow that? Okay. Because if you like, some people will like solve and move the numbers over and get the variables and then drop them all out if you just did that way. But once those variables drop out, you can just ask yourself, true or false statement.